I hope you enjoyed watching the ZX81 video as much as I enjoyed making it. You may notice I've been writing small programs and using them in my computer videos to explain certain points, and because I love to code, I probably spend much longer making them than is strictly necessary. One staple of all the videos that I've done, other than the ZX80 video where you just can't do it, is a bouncing ball program. It's relatively easy to write and it shows the speed of each computer and its graphics capabilities, or lack thereof. I made one for the ZX81 using the plot command, which is the highest resolution graphics on Sinclair's budget machine, and as you can see, it's not very quick. And that's the ZX81's major problem running BASIC in slow mode. It's really, really slow. But it got me thinking, would it be possible to write a breakout style arcade game for an unaltered ZX81 other than a 16K RAM pack and using BASIC? So no tricks with emulators by speeding up the ZX81. This would be a program that would run on an original ZX81 with the 16K RAM pack. The first thing I tried was adding a bat to the existing ball bouncing demo. You can use the in-key command to read key presses, and I used character graphics for the bat, which meant translating between the print at y and x coordinates to the plot's x, then y coordinates, which are double that of the print at. The two completely separate coordinate systems, but it's not difficult to work it out. But anyway, that worked fine, but as you can see, it's a pretty glacial game. Maybe it'd be faster, instead of using the plot command, I could just display the letter O for the ball using the same print at command that I used for the bat. So I tried that and it's faster, but it's still not great. Then I tried limiting the screen size to something more portrait by making a smaller gameplay area. It might make this a bit more playable. And now we're starting to get somewhere, but this game is going to get slower when I add more code to check for hitting bricks and many other things that I need to do in the main game loop. So the ball bouncing needs to be faster. I could make the gameplay area even smaller, but tiny games in the corner of the screen were a hallmark of limited 1K ZX81 games, and my eyesight isn't getting any better as I get older, so I'd like it to be full screen. The alternative is to only print the ball every 2 squares instead of every square. It has the additional advantage that it makes it harder to react to the ball with a bat that's now effectively twice as slow. That's good, as the game before was a little too easy. Now we're getting to something that's more compelling and fast enough. One problem of printing every other square is more problems with boundary checking, both at the edge of the play area, hitting the bat, and when hitting bricks. So I had to spend more time debugging those parts, but that's not a hard problem to solve, and crucially it doesn't slow the game down. Our enemy with this game is speed, so you have to be very careful with what you put in the main game loop. Every bit of code that's executed every time the ball moves is going to slow things down. One of those things is brick detection, so that's what I tackled next. Given the ball goes every 2 squares, you can't have 1 brick every square or you'll never hit the odd squares. So I put a set of 10 bricks on every other pixel. To track each brick, I put it in a 10 number array. Each element is set to 1 if the pixel is still there, or 0 if it's been knocked out. The only extra code I need to add in the main loop is to check if the ball is on the same row as the bricks, and this means it doesn't slow the program down too much. You can see that it gets a little slower when the ball gets to the brick line, but in my opinion, that's acceptable. For some reason, I found that even with this, it only hit half the bricks, plus having the ball only go diagonally isn't that great when you think of how the ball bounces off a bat in games like Arkanoid. My first stab at ball physics allowed for a ball that, instead of going 2 in the x direction and 2 in the y direction, now goes 1 in the x direction and 2 in the y direction. That gives the ball more chance of hitting all the bricks, but the physics were still a bit out of whack. But all this is a great proof of concept, because it proves that the only thing stopping me of making a good breakout game on the ZX81 in BASIC was speed, and I've already proven that I could solve that problem. The next challenge was making a breakout game you'd actually want to play and that was solvable. So the next step was better ball physics when it hit the bat. That took a little more thinking and a lot more code, which I thought would slow things down, but this code isn't in the main game loop. It's only called when the ball is on the same row as the bat, and it wasn't too onerous that it slowed things down too much. Physics was now a solved problem. Now I needed to fix some of the bugs with brick detection and with the ball sometimes going out of play if it hit the bat in the corner at just the right angle. A good way to do this is to replicate problems by starting the ball at exactly the same point that will always replicate the problem, and also showing the path it took and putting text to debug what variables are doing. That breadcrumb trail showing where the ball has been showed me that I could put bricks all along the top, not just every other square, and I used different types of brick to break it up and make it look a little bit more interesting. Okay, so now I've got something resembling a finished game. If the bat misses the ball, it's game over. If you get all the bricks, then you've won. But if you finish the level, should you get to play again? Whilst debugging it, I found that if I moved the line of bricks down, it would make the game harder. If I started the bricks on row 2, that could be level 1. If I started them on row 4, it could be level 2, and so on. So that was the next step. So the new game now displays the whole screen in slow mode instead of drawing it in fast mode as I'd previously done. And the reason I did this is because when I make a new level, I don't want the program awkwardly blanking the screen in fast mode every time you've won a level. In any case, I quite like how it loads the screen slowly. You press 0 to start the game and keep going until every brick has disappeared. When that happens, the screen resets, the bricks draw one stage lower, and you go to the next level. Keep going and see how far you get. This is all very well, but it was still missing some playability. Like on other Breakout games, getting the last brick can be agonizing and annoying. How could I make this game a little bit more fun? The final addition I added was the concept of zaps. In Arkanoid you get bonus items drop down, and I thought I'd add my own. If a brick is hit, there's a 1 in 5 chance a zap will drop down. If you catch it with the bat, then you get one more zap. If you press 9, then you can use a zap, which will remove the leftmost brick. This is useful if you're down to your last 1 or 2 bricks that you just can't get. You can simply remove them and then go on to the next level. And like Arkanoid, there's the challenge of picking up this precious bonus whilst also trying to bounce the ball. The downside is that with a zap heading down the screen, we're starting to see the game slow down. Thankfully, it doesn't happen that often, and I think it's a good trade-off between speed and gameplay. You could just award a zap without having to collect it, but then where's the fun in that? So there you go, a playable, I hope you agree, Breakout game written in BASIC for the ZX81. There are probably many better basic Breakout games for the ZX81 that have been written, and I purposely didn't go looking for them so I wouldn't copy them. But I'm happy that I've made something that I find fun, and I hope you do as well. I'll leave a link to the final program in the description if you want to download it and try it for yourself. Anyway, thanks for watching to the end. I hope you enjoyed this slightly different video, and I'll see you in the next video.